pilot. So let's try a bit of different programs here. And if they stand the test of very many quantifiers, then they are implemented right. Let's do set. And set goes into a mode. It wants to actually replace a bunch of A's. This is 32 A's, by the way. And set didn't have a question mark, so I had to do stars. But that's no problem, because that makes the problem harder, right? I am very fast, it says. What actually happened here? Well, go back to this one. What it does, it goes into all states simultaneously. That's very cool. It takes all the choices at one point. It just says, do I match a P? Do I match an E? If at any point something doesn't match on either of these paths, it just falls away. But at any given point, it keeps a list of positions in this. So it does all the work sort of simultaneously, not exactly at the same time, but sort of in the same iteration. It can go through the whole string from one end to the other, and it never has to backtrack because it keeps in mind all the alive paths that it has. And set does this. What else does this? Let's check awk. And again, we have to input this 32A string. Awk does this. Nice. A lot of old stuff does this, apparently. Set and awk. What about grep? That red one is a grep. It matched it incredibly fast. Ruby.
You see how similar Ruby syntax is to Perl syntax, right?
Maybe they were inspired by something, I don't know.
They state so.
Now, this is the first one we don't get a response on. My guess is that it went away for a very long time, and we shouldn't expect it to come back. And I could control C here, but unfortunately...
2 is better.
Control Z.
It's very persistent.
I'm nearly there.
Phew. What about Python? Now, as you know, Python comes with batteries included, which is why you have to import regular expressions. That cracks me up every time. You also have to import math,
They
right?
come from the future in your universe?
Right, at least, yeah, if they import regular expressions from the future, maybe they will be fast, yeah.
No, they started with a minimal kernel and added things to it.
There we go. This one also takes a very long time. Notice that set and awk and grep, they just came back immediately. Whatever they did on the hood, they did it very fast. And they do this list thing. Fortunately, Python allows me to abort things. They have that function on. What about Perl? No, 5.
Which 5?
You know, that seems to be the topic of this conference. Which profile?
Yes,
Let's do a version before, because people ask. 5.14, I'm so sorry. This is Mint, yeah. So something Ubuntu-ish. Now this surprised me. This is the case where I was wrong. And apparently I was wrong twice. I can stand here while it runs. So I thought that Perl 5 hadn't done anything about this at all, that it was sort of a misunderstood regular expression implementation, just like Python and Ruby. But then I tried this at home, and it was blazingly fast. I couldn't get it to sort of take longer than a couple of milliseconds. And then I get to the conference, and now it's slow again. So I'm waiting for someone to explain this to me.
Version at home.
The same version. I was on the same computer both times, on the same virtual
That
machine.
doesn't make sense.
That doesn't make sense, I know. But I didn't want to lie to you and say, wow, this is blazingly fast. Anyway.
That one won't be done as a tree.
Right, I know that there are trees involved, and I expected there to be here, but apparently there wasn't. Now, Moritz has actually written a blog post about this, how hard it is to get Perl to perform in exponential time. And you see a couple of things that you can do here with stars and stuff, and it just takes very, very short time. And you can go in and debug the regular expressions, and you can see that it does guessing here, guessing the start of the match against just a constant string. And if it finds a match immediately, it realizes, hey, I don't have to go through all this star stuff or question marks, because they will just fail anyway. If you have sort of a string with one length and the regular expression with a constant string of the same length, you have to choose the constant string. Everything else will just fail. So it takes a really smart shortcut there. And to cheat the system, you actually have to do something as complicated as this. This is the quantifier that says I want to match between 1 time and 32,000 times. Now we talked about the star and the plus and the question mark, but this can essentially also be constructed from just variants of vacuum cleaners. So yeah, that took a long time as well. And then there is our final hope, Perl 6. And when I run Perl 6, I just have to change it into 6, right? It's exactly the same syntax and everything, right? No, unsupported use of this match operator to do pattern matching. That's actually one of the RFCs. They said, please get rid of that ugly match operator. Let's call it this. I hear the Perl 5 people like this one a lot.
Yeah, like maybe an interesting song, yes.
And we did this one, and it definitely didn't come back immediately, at least. So this is the disappointment, and I won't make any promises up on stage, but I will definitely look into this. I know that there are state machines underneath, and I think this should definitely be as fast as it is.
I believe I know why.
Larry believes he knows why.
Yeah, because it's actually, it's doing, trying to do a longest token match on the front, and that does use the DFA fast engine.
Oh, that's a
Then
shame.
it's actually reparsing it using the backtracking engine to find where all the brackets are, and there aren't any brackets, so it shouldn't do that. That optimization is not going to put in here.
So an optimization could save the day here and make it very, very fast. So no promises, but I'll definitely look into this. It's state machines underneath. It's things that I've been talking about today, so it should just be going in there and doing it right. Yes, a question up here.
I don't know if it was the same answer, but as far as I know, it takes the longest constant string first. Because there's this optimization, this
Yes.
algorithm to take, you know, if you're looking for cat, it doesn't look for C-A-T.
Right.
It jumps 3 in advance, and then it looks which character it sees.
Right.
And if it's C-A or T, then it goes, if it's an A, it looks 1 further. If it's a T, and then it's much faster. I
It's
don't remember the name of the algorithm.
Boyer-Moore string matching, yes.
Yes, and for this to do, it takes the N, all the A's,
Right.
and looks first at this as an anchor, and then it goes backtracking.
We're down to about +6.
We have a different optimization in Perl 6 that is not Boyer-Moore. Now Boyer-Moore is very
Sorry, I was
clever.
talking about Perl 5.
Yes, I know, yeah. I realize that. Yes, Perl 5 does horribly clever things to your regex. It makes your regex seem instantaneous in most cases because it does all these optimizations. And there are
Most of which are cheats.
decades poured into the regular expression matcher. You know, you go back in the Git log and I just expected, oh, the last commit was probably like 5 or 6 years ago because it's so stable now. No, things are happening several times a month, just commits all the time. And now we don't do Boyer-Moore in Perl 6, we don't do tree matching. We do these DFAs, and I'm going to talk about this a bit more in the slides. So we have this one. We'll get back to that. one question, of course, is how far can you get with state machines? The things we call regular expressions these days are actually quite advanced. And they are not so regular. They are not just these three things that I showed as operators. For example, you can actually run code inside your regular expression. On a more or less unholy way in Perl 5, it says this syntax is experimental, and in a fairly systematic way in Perl 6. But you can do quite a lot with just the regular expression, just the original thing that was called regular expressions. All the way up to matching and capturing things. You can do that with a little trick, basically running the string backwards as well. What you cannot do, however, is using those captures, for example. So this \1, what does \1 do?
Use the capture you found earlier in the same expression.
Yes, it uses the capture you found earlier in the same expression. And that's basically the limits of these DFAs, of these regular expressions. You cannot put in something that just turned up during the actual match that you're doing now. It's too static for that. And if you were to try to do that, you would essentially push yourself until you were back at the stage where you have the long form of backtracking again, where you have to try several different things and they take exponential time. But the takeaway here is that a lot of things are possible, and sort of a hybrid approach would kind of rock. So a little about Perl 6 regexes. These grammars that you build, they build state machines for you under the hood. So you just write, well, the equivalences of methods. You write regexes and tokens and rules, and they all call each other. And behind the scenes, there is something that puts together these gigantic state machines for you, so you don't have to care about it. And it is the best of both worlds, except that this particular case does backtrack exponentially, and we'll look into that. We have something called declarative prefixes, which is basically for any rule, token, or regex, you probably have something in the beginning of that that's completely possible to turn into a state machine. That's completely regex in the original definition. And then at some point it turns over and becomes hairier than that, and then you just switch over to the normal machine. But for a bunch of cases, you probably will get away cheaply, and you can do this non-backtracking regex search that we talked about here. And not only that, Perl 6 actually goes in and takes all these declarative prefixes and sort of combines them, mashes them together into one big alternative. So usually, you know, you'll have a matching tree with rules calling each other, and it just takes all of them, all of the declarative prefixes, it finds along all the way, and builds one big tree of all those. So that's the optimization we do instead of Perl 5's tree approach. All this is, of course, meant to encourage composability. You take different grammars and you have them call each other and so on, and the state machine thing just works out all the way. In fact, it's better than that. Grammars are just a special case of classes in Perl 6. And with classes, you can inherit, you can take your letter ascending grammar and make it a formal letter instead, and it's just changing a few rules somewhere if you factor it right. But you can also pull in roles and mix in roles into things. And what's a role here? Usually a role is something that contributes methods, and these methods are just provided in your class and you can use them. Well, here the methods are rules or tokens or regexes, and they work in exactly the same way. If you know how to mix in a role into a class, you know how to do it in a grammar. And this leads to cases where we don't know at some part of the compile time exactly how our DFA will look, exactly how our state machine will look, because the rest is off in a role somewhere. And we just leave a sort of insert me here point, like I did with the IKEA diagrams. And the role comes and provides the last bit of the state machine in the end. So that's quite important to realize. This is Perl 6 building these state machines for you in the nicest possible way, because as a user, as a programmer, you're only working and thinking up on the grammars level, where everything is nice and looks like Perl. So, that's it. Thank you. And I believe we have a few minutes left for questions. Yeah, about 4 or 5. Yes, hello.
You can say what I was at Perl 5.
the fix which the exhibition did in 510 was to change recursive behavior, backtracking to iterative behavior. It made it actually safer but slower, a bit slower. And you have to use RE2 from Russ Cox, which is like in this paper, and then you get the faster.
Did that happen after Perl 510?
RE2 is something like 5.8. It's just an external engine.
I see. So it's not the default yet.
No.
Okay.
Now you have to check, because RE2 doesn't support all our syntax.
Right.
Nobody wrote the patch yet to check if we have that many quantifiers and no backtracks, and then we can use RE2.
Right. So RE2 at this point is an optional add-on.
Yeah.
Or optional
Sometimes I
plugin.
use it.
Right.
Maybe better.
Oh, cool. Thank you for that.